This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We've been talking about graphing secant and cosecant, so we're going to look at a few examples here. And the first one we have is f of x is equal to 5 secant negative 4x. So whenever we're doing these, my recommendation is to just pretend that we're graphing the reciprocal function. So let's pretend it's f of x is equal to 5 cosine negative 4x. Okay? And the very last step in our graph will be to actually graph the secant. But the easiest way to do these is just pretend that it's the normal trig function, the sine or the cosine. So let's go ahead and figure everything out as if it was cosine, and all of this is going to match, except when we get to the graph, when we're going to have asymptotes where the value would normally be 0, because when we do the reciprocal, that'll be undefined, and the curve is going to be different as well. So for A, we've got 5. For B, I have negative 4. C and D are both 0. The domain for this is we're not really going to worry about, but it's going to be all real numbers where x cannot equal, because we've got to get rid of those values where it's not equal to 0, because when we do the reciprocal, it's going to be undefined, where x does not equal pi over 2 times, we'll just say k. So any multiple of pi over 2, the range, it's going to be, since our amplitude is going to be 5, and these are going to go up and down, and again, we won't really worry about range too much. So it's going to be y is greater than or equal to 5, and y is less than or equal to negative 5. And if you want to write that in interval notation, that's fine. Amplitude is still going to be the absolute value of a, so that's going to be 5. The period is still going to be 2 pi over b, so that's going to be 2 pi over negative 4, and again, this is going to be the absolute value, so that's going to be pi over 2. My phase shift, c over b, so that's going to be 0. My vertical shift is d, that's going to be 0. And distance between key points is still period divided by 4. So that's pi over 2 divided by 4, or pi over 8. Alright, so again, here's my x values, here's my f of x. We're just going to pretend again that we're graphing 5 cosine negative 4x. And since there's no phase shift, we'll start at 0, and then we're going to go up by my distance between key points, so that's going to be 1 pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. And these two will reduce, so that'll be pi over 4, and this will be pi over 2. Let's go ahead and substitute these in. I've got 5 cosine negative 4 times 0, which is 5 times the cosine of 0, which is 5 times 1, because it's 0. Remember, on our unit circle, at 0, the cosine is 1, so this is going to be 5. Then I've got 5 cosine negative 4 times pi over 8. So I have 5 times the cosine of negative pi over 2. This whole thing simplifies to negative pi over 2. So negative pi over 2, we're going to be down here. We're just going around the circle backwards. So that's 0, negative 1. My cosine is 0, so that's 5 times 0, which is 0. And then I have 5 cosine negative 4 times pi over 4, which is 5 times the cosine. that's just going to be negative pi. So that's 5 times. So negative pi, we're going to be over here. That's negative 1, 0. The cosine is negative 1. So that's negative 5. Moving on, we have 5 times the cosine, negative 4 times 3 pi over 8. And if you need to do more work to simplify these, feel free. I'm just kind of going through it quickly. So this is going to simplify this whole thing in the parentheses to negative 3 pi over 2. So that's going to be 5 times. So negative 3 pi over 2, we're going to go clockwise direction until we get back to the top. That's negative 3 pi over 2, which is the same as positive pi over 2. That's 0, negative 1. My cosine is 0, so 5 times 0 is 0. And last, I have 5 cosine negative 4 times pi over 2, which is 5 times the cosine of negative 2 pi. So that's going to be 5 times, so negative 2 pi, we're coming all the way around. My cosine is 1, or 5. So let's go ahead and let's graph this. Let's mark each of these a pi over 8. So 1 pi over 8, 2 pi over 8, you can reduce them as you go if you want, or not. 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 7 pi over 8, and 8 pi over 8 would be pi. And I know I need to go up to 5 and down to negative 5. Okay, and I've got 0, 5, and then pi over 8, 0, and then pi over 4 is negative 5, and then 3 pi over 8 is 0, and pi over 2. Okay, so be very careful here. This might take a little bit of getting used to, but we're going to dot in this cosine curve, because it's not really part of the secant curve, but we're going to use it to help us. Alright, and then I'm going to go ahead and I'm going to do one more period of this. Doesn't matter whether you go to the left or the right, so then my next point will be there at 0, and then negative 5, and then 0, and then positive 5. Again, I'm going to dot this in. So this would be what it would look like if it was cosine, but it's not cosine. That's why we dot this in, because it's not really part of the secant curve. Now, I have these 3 points that are maximum values. These are up at the top. And then I have these 2 values down here that are minimum points. These are at the bottom. Then I have these 1, 2, 3, 4 spots that are in the middle. These spots in the middle are always the spots that are going to make the cosine 0, which means the secant is going to be undefined. So at all of these spots that are in the middle, which will make my secant curves undefined, this is where my asymptotes are going to go. So for this graph, I've got 1 asymptote, 2 asymptotes, here's a third, and here's a 4th asymptote. Okay, so here's my asymptotes. Now, once I have this drawn in, I can go ahead and I'm going to take all of my cosine parts in between the asymptotes and kind of flip them. Okay, because again, it's the reciprocal. So over here, I'm going to flip this, and it's got to go up and approach the asymptote. And down here, my U-shape goes up, so my U-shape for my secant is going to go down. And then here it goes down, so I want to flip it so it opens up. Okay, here's another one that's going to open down. And then don't forget this quarter period here. You have to approach the asymptotes, and you want to sort of mirror the cosine curve that we drew in. So really, the green portion here is our actual secant curve. Everything else we've just drawn in to help us, and these are all things that I'm going to be expecting to see when you graph these as well. So if you have any questions, make sure that you ask me. Otherwise, move on to the next example, and we'll see you there.